this video, we're going to look at how we can solve probability questions using the normal distribution. This video in particular is going to look at how we can use the normal distribution to solve probability questions over an interval. We're also going to look at how we can use confidence intervals to solve those types of questions by hand. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defence company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The normal distribution is actually a special kind of probability density function described as follows. It isn't particularly important to memorize this equation for the exam, although some schools will teach it anyway. Of special note is that the normal distribution uses the mean and standard deviation as its transformation factors, where the mean is a horizontal translation and the standard deviation is a dilation factor. There are two main qualities worth discussing when it comes to the normal distribution. The first is that it's always centered at the mean. 50% of the probability will always be to the left, and 50% will always be to the right of the mean when it comes to the normal distribution. This kind of symmetry is very important for solving these types of questions, either by hand or by CAS. The second is that the standard deviation is responsible for the shape of the curve. A larger standard deviation is going to result in a wider, flatter curve, and a smaller standard deviation is going to result in a much taller but thinner curve. The vast majority of normal distribution questions are going to look like this. You're going to be told that your probability is normally distributed with some mean and some standard deviation, and then you're going to be asked to find a probability that x is between some interval, which in this case is from 140 to 170. As mentioned earlier, the normal distribution is just a special kind of probability density function, so all the rules that apply to those also apply to the normal distribution. So, presumably, we could just take the integral from 140 to 170 and just solve it that way, which is doable, but it's on the slower side, and it would be a nightmare to do by hand. The CAS actually has inbuilt functions for these normal distribution questions. The TI Nspire has norm CDF, which you can find under probability, distributions, normal CDF. All you're going to do is plug in your upper and lower bound, the mean, and the standard deviation. The Casio has a similar function, located under interactive, distributions, continuous, norm CDF. And once again, you're going to get a very similar setup window where all you're going to do is plug in all of those required terms and get your answer. So, why did we get three slightly different answers? Well, the true reason is I don't actually know, but it has something to do with how the algorithms were actually implemented on the CAS versus the Casio. They only have to be accurate to a certain number of decimal places, which is never going to be an issue for the exam, since you'll only ever cap out at roughly 4 decimal places. So rest assured, it doesn't matter what method you use, your result will be accurate enough regardless. Sometimes you're going to be asked to find either the upper or lower bound of some given interval when you already know the probability, like this question here, which is asking us to solve the value of k such that 80% of scores are below. This is where the inverse normal function comes into play, which on the TI Nspire is located under probability, distributions, inverse normal. All you're going to do is plug in the probability, in this case 0.8, as well as the mean and standard deviation. This is going to give you the k value that we're after. On the Casio, it's actually slightly better. It's located under interactive, distributions, inverse, inv-norm CDF. The reason it's slightly better is because you can actually determine whether you want your probability to be defined to the left or to the right of the k value that you're after. Our inequality was a less than sign, so we're going to select left, since you want everything to be left of your upper bound. If it was a greater than sign, then you would instead select right. The TI Nspire doesn't have that option. So when you're given your probability, you need to use complement probabilities to flip that so that it's pointing to the left rather than to the right. For example, if x greater than k equals 0.8, then you would have to flip that to write x less than k equals 0.2. 0.2 is what you would then put in the CAS. Confidence intervals are also a common question that comes up in the normal distribution. All a confidence interval is a certain probability that is contained either side of the mean. For example, the 68% confidence interval is roughly contained between plus and minus 1 standard deviation from the mean. The other two confidence intervals are the 95 and the 99% confidence intervals, which are plus or minus 2 and plus or minus 3 standard deviations respectively. The most common one is the 95% confidence interval. These approximate probabilities can be used to solve normal distribution questions by hand, like in this example here, where we're told that the mean is 100, the standard deviation is 15. We're told to use that information to figure out the probability that our score is going to be above 115. In this case, we can see that 115 is just one standard deviation to the right of the mean. Mean is 100, plus 15 for the standard deviation gets you one standard deviation to the right. We know that approximately 68% of the probability is located one standard deviation either side of the mean. That means 34 to the left and 34 to the right. We also know that 50% of the probability is always located left of the mean. So when you add those two things together, the 50% to the left of the mean plus the 34% that is between the mean and one standard deviation, you're going to get a total probability of 84%. So if you want to find the total probability to the right, then you're going to find the complement to 84%, which is 16%. If you got this question in a TechActive environment, then you would just use the normal CDF. You'd have a lower bound of 115 and an upper bound of infinity. I just want to highlight that use of infinity for a moment. The normal distribution itself is defined for all real numbers, so it spans from negative infinity all the way up until positive infinity. So, if your probability is considered normally distributed, then you need to ensure that all of your unbounded inequalities approach infinity or negative infinity depending on which direction they point in. This is true regardless of the type of context of the question. For example, this question here was talking about the heights of a group of people being greater than 180 centimeters. It obviously makes no sense for someone to have an infinite height, but we're still going to put our upper bound as infinity because the normal distribution expects that. The normal distribution itself is just an approximation of what the true probabilities would be like. So don't get too hung up on the impracticality of using infinity in these situations. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.